Bienvenidos, Ushamdi, and welcome, CTS230, Section 841 students for the first 8-week term of the Fall 2017 semester at Anne Arundel Community College. This is the Networking 3 course, or the Cisco Networking Academy's Scaling Networks V6 course, and this morning's Packet Tracer video tutorial and solution set is going to be on Packet Tracer Activity 10.1.3.4, where we're going to take a look at some of the Ospf v2 advanced features. So let's go ahead and dive into the activity here. We're going to be manipulating the hello and dead interval, and then we're also going to be taking a look at doing a little traffic engineering at layer 3. And they're using the bandwidth command down here over on the right, and we're going to talk about the preferred way, or the more technically preferred way to approach this, and that's with the IP-Ospf cost command. And we'll discuss why you might not want to use that bandwidth command. So first, let's test connectivity. I'm going to pull PC3 up here, and I believe that we are supposed to have connectivity, I believe we are supposed to have connectivity all the way out to the internet at this point. And the internet being this web server here. So let's say ping 64.100.1.2, and let's see if we can make our way out of the Ospf environment and to the internet. And so we do have full connectivity. Now, if I was to say trace RT for trace route 64.100.1.2, you can see that we go to 10.9, and that's router 2. And that makes sense, right? Because router 2, and that's a consistent second hop there, right? We're going to 10.9, which is router 2. And that makes sense because that's the quickest way out of the environment, the shortest path out of our environment. Now, what do we want to do here? Well, they're going to have us change the hello and dead interval between routers 1 and 2. So let's pull router 1 up here and give ourselves a little more space with which to work, and we'll get the CLI up here. And we're going to go into privilege exec and then config T to get into global config mode. So if I was to say do show IP-Ospf neighbor, you can see that our connection over to router 2, who is obviously that 209.165, there's the router ID, priority of 0. Why do we have a priority of 0? Again, remember, there is no DR-BDR election on a point-to-point link, right? So we are fully adjacent with that neighbor, but there is no DR-BDR election. We have our dead timer, and then we have the IP address of the neighbor, and then we have the interface out which we contact that neighbor, right? That serial 000 interface is the interface out which we're contacting, or we have connectivity with router 2. So when we take a look at this, they want us to change the hello and the dead interval. So let's get into interface serial 000, and we're going to simply say IP-Ospf hello interval, and we're going to change it to 15. Now, if I was to say do show IP-Ospf neighbor, take a look at the dead timer here. Remember, the hello interval needs to match. It's being communicated in the hello packet, and you can see that we are now on the countdown to extinction here, out that serial 000 interface, because the timer is dropping all the way down. We're now below 10 seconds. And let me set the dead interval. So IP-Ospf dead interval, we're going to make it 4 times the hello interval. Now the neighbor adjacency has gone down, so a do show IP-Ospf neighbor, that adjacency is gone because the hello interval did not match. Now, let's see, it's going to fail. Yep, so we're going to go up here to router 2. We're going to pull the CLI up for router 2. And let's go ahead and do this. We're going to go into privilege exec, global config, interface serial 000, IP-Ospf hello interval, and I'm going to set it to 15 so that it matches. Now you'll notice I'm not setting the dead interval. And by default, what would the dead interval be? Right, it would be 4 times the hello interval. And what is 4 times 15? Well, 4 times 15 is 60. So when we take a look at this, if I were to say do show IP OSPF neighbor, whoops, do show IP OSPF neighbor, you can see that we still only have that single adjacency, right? Now that's interesting because 4 times the hello interval would be 60, but it's not coming up. So let's do this. Let's go ahead and say IP OSPF dead interval 60. And should this be enough to bring the OSPF adjacency back online between these two routers? So do show IP OSPF neighbor, and of course it preempted me there. And absolutely, we went from loading to full. Now this raises the question of why didn't it know that the dead interval would be 60, that it would be a match? And let's see what real Cisco IOS routers would do in a scenario like this. So here we are on, and actually we're going to have to do this on router 8 and 9, and this is where my serial connection is. So if I was to come over here and say show IP interface brief, and let's get into global config interface serial 000, and we're going to say no shut IP address, and we'll use 192.168.89.8 because it's going to be between routers 8 and 9, and I'm going to say router OSPF 1. We'll set our router ID to 8.8. Well, actually, we've got that loopback address, so we're going to be good there. And then interface serial 000, IP OSPF 1 area 0. And we'll come over to router 9, and we'll do much the same thing here. We'll get into global config. We'll say router OSPF 1 interface serial 000, no shut, IP address 192.168.89.9. Make it a /24, IP OSPF 1 area 0. And so we should be able to ping 192.168.89.8, and we can, and actually we saw real quickly there, it popped up, we went from loading to full. So if I was to say do show IP OSPF neighbor, right, you can see that the adjacency on router 9 is with router 8, and it's out this serial 000 interface. So very similar to what we're looking at right now. So now let me go ahead and say IP OSPF hello interval, and we'll change that to 15. Now, when we rerun that show IP OSPF neighbor, take a look, we're at 32, we're at 30, and now we begin the countdown to extinction because, again, the hello packets are recognizing the fact that the hello interval, do debug IP OSPF hello, they're recognizing that the interval is different, right? So take a look here. When we do that debug IP OSPF hello, what do we see? Mismatched hello parameters from router 8. And what do we see? It even tells us right there, and this is all in the hello packet. So we see that we are receiving a dead interval of 40, and ours is 40, and we're configured for 60. So I should say, let me make sure I'm clear on this. And let me stop this. Let me say do you all, because I'm trying to read this as it's flying by here. So what is that saying? So this is saying that the dead interval that we are receiving is 40. Because again, router 8, we haven't made any changes on router 8. So we're receiving a dead interval of 40. Excuse me. We are configured for 60. Because all I've changed is the hello interval, but the router OSPF knows that it's 4 times the hello interval. And take a look, what is the hello interval set to? We're receiving 10 from router 8, because nothing's been done to router 8, and we are configured for 15. And so again, OSPF here on router 9 knows that if we're configured for 15, that the dead interval is going to be configured for 60 because it's the default. By default, it is 4 times the hello interval. And then the countdown to extinction takes place, and then ultimately what happens, we go from full to down. So let me do this. Now I'm going to configure, just like we did in the other activity, I'm going to say IP OSPF dead interval, and we'll set it to 60. And again, remember, we had the conversation, because if you're scratching your head saying, wait a second, if OSPF knows that it's 60, right, because it's 4 times the hello interval, why are you typing that in? That's kind of redundant. And in a sense, it is. However, it's not from a logical standpoint. So do show run interface, and here's what I mean by that, is that it makes sense, and you know what? It's ironically, it's not even going to put that in there. So it looks like it didn't even put the dead interval in here because it would be the default of 4 times the hello interval. So if I was to set it to 45, right? So let's set it to 3 times the hello interval. And it doesn't put it in here. So it makes sense from this perspective when it's not the default, right? So when it's the default, you'll notice it doesn't put it in there. I'll put a little question mark here. It doesn't put it in here because it's expecting you to know that the default is going to be times 4, which would give us 60. And that's what we configured here that does not show up down here. But when I set it to 3 times the hello interval, it does put it in here. So again, another instance of where Cisco with a default is not going to show it in the interface configuration. And this has got me curious now. I'm wondering if Packet Tracer cooperated on that. Do show run, and let's see if it put it in here. Yeah, so interesting that Packet Tracer puts it in here. Real Cisco iOS is not going to do that. And this is 15.3 code, right? And maybe it's it varies with different code, but here with 15.3 code, we are not see. I'm sorry, 15. This is 15.1 code on this router 8 and 9. These are 28.11, so it's 15.1 code. So it doesn't put it in here. But here's what we want to see. Does the dead interval need to match? So let's go to the interval here of 45. So we're going to pull this off of router 9. In other words, do I have to type it in to force the match like we did in Packet Tracer? And so let's see, do show run interface serial 000. So again, the hello and dead interval are 15 and 60. To check this, I could say do show IP OSPF interface serial 000, where it's going to show me right here the hello and the dead. And remember that wait timer, that's for our DR, BDR election. It's going to wait 60 seconds to find somebody. If not, and we're on a multi-access segment, it would elect itself as the DR. But again, here's the hello and the dead interval, and that's what we're interested in right now, right? So let's go over to router 8, and let's see, do I have to type in, let me make sure I'm under the serial interface 000, do I have to put the dead interval in like we did in Packet Tracer? IP OSPF hello interval, or is it smart enough to figure out right now that since the hello interval is 15, that the dead interval will auto-magically be 60, and will it bring my adjacency back up? And that is what I was anticipating was going to happen. So there's a couple things that we've seen here where there's significant differences between Packet Tracer and the behavior you'll see in real Cisco iOS. And the first one is that is the default. It will not appear, again, and I'm 15.1 code, so it will not appear in the code that we're running. Don't expect to see that in the running config. The reason that you would try to put it in there, like I did initially over here, only to find out we're not going to see it, is that you want to make sure that someone coming after you, if they were to look at your config, has an idea of what's going on. Because maybe you've shrunk the hello interval to 15 and you wished to tweak the dead interval, right? Maybe you wanted to tweak the dead interval. And so that's what's going to happen. That's why you would want to make sure you make that adjustment. and put it in the config. But again, it's only going to show up in your config if it's not the default. And again, that may be version specific. I don't believe that it is, but it might be version specific. So make sure you check and see what the case is on your side. And then that second difference that we saw is that, remember over here, I had to type in IP OSPF dead interval 60 or it wouldn't bring the adjacency back up. But over here, all we needed to do was put the hello interval in because, again, do show IP OSPF interface serial 000. OSPF is smart enough to know that, hey, whatever you tell me the hello interval is, I'm doing 4x on that for the dead interval. And then it's going to bring that adjacency up. So let's transition back over here, and now we're going to kind of wrap this activity up. It says adjust the bandwidth setting on R1. So we want to trace the path because they're basically going to do, we're going to do some layer 3 traffic engineering here. So I'm on router 1. I'm going to say trace route over to the 64.100.1.2. And you can see from the PC, the first hop is our default gateway because the PC realizes that that is not a local network. I'm going to have to go to my default gateway, and it does, and then it goes to router 2. And that makes sense, right? Because router 2 is closer to the destination than router 1. And router 2 is probably, I haven't looked yet, but it's probably the originator of the default route. And you can see it's consistent, right? We go to 172.16.3.2 on that second hop every time, right? And if I was to come to router 1 where this decision is being made, let's go into privilege exec and let's say show IP route. And do we have? We do. We have that default information originate on router 2 is what it appears. And you can see we've got this OE2, right? This OSPF external, right? Type 2 external routing information. So that's a type 5 LSA. If I said show IP OSPF database, you can see we've got a type 5 external link, right? And that's what the LSA is. There's the network, right? Is this quad zeros, the advertising router, the router ID of the advertising router. And this is another great example of when you would want to have a router ID manually configured with that router ID command. And again, remember, always, always, always set your router ID manually with some convention that you stick to, that's consistent, so that you can more easily identify the routers in your environment. There's the age of the link state. Remember, that's going to count up, so it's in by seconds. And remember, when we hit, and it'll be about the type 1 LSA, right? Remember, when we hit 30 minutes, and this is that little semantical game that was being played in the text, was OSPF doesn't reflood for no reason, right? Like, RIP is gonna reflood everything in the routing table, right? Every, I want to say 60 seconds, I think. It's going to broadcast out. It's going to flood everything out every 60 seconds. And the text said that OSPF does not send out incremental updates, right? It doesn't send incremental updates. And while that's true, that it doesn't send, and I'll do the little double quotes, the quote-unquote updates, it does refresh. It sends a refresh for all links for which it is responsible every 30 minutes to ensure that no other router maybe has a corrupted entry for the information for router. We're talking about router 1 here. So for router 1, or maybe it lost that routing information for whatever reason, right? So every 30 minutes, OSPF will send a OSPF router will send a refresh, right, of only the links that it is responsible for. So it doesn't send its entire RIB. It only sends out information for the links it's responsible for. And they call it a refresh, right? Not an update. But you could make the argument that every OSPF speaking router every 30 minutes sends out an update on its links. And again, it's that semantical argument, right? You're kind of like splitting hairs when we say refresh versus update. It's like, okay, so sure, we can make a difference. I guess you could say there's a difference there. But remember, every 30 minutes, every OSPF speaking router will refresh, send out a refresh, right? It may not be a link state update message, but it's going to send out or it may not be an update, but it'll send out a link state update with a refresh that has its information, right, for the links it's responsible for. And so you can see we go through router 2 here, right? And actually one more important thing is that this is what Andrew had asked about, the tag value. So when you redistribute information from another routing protocol, like the static protocol, or EIGRP, or RIP, or BGP, when you redistribute information from outside the OSPF domain into the OSPF domain, you can put an external tag. There's actually a field in the LSAs where you can put an external tag, and why you would want to tag that information is maybe you want to do something, right? You could have a route map that would then manipulate that redistributed information based off the tag value, right? So maybe all routes that you're redistributing from EIGRP into OSPF, you want to tag those with an external tag that corresponds to the EIGRP autonomous system number, maybe, because then you know where all of that routing information, when you look at your link state database, you know when you see tag 99 that all of the routes or the prefixes tagged with 99 came from EIGRP autonomous system 99. And so where is that tag value coming from? Why does it say tag 1? So by default, when you do the default information originate command, and it's the same thing with OSPF v3 or OSPF for IPv6, it's going to tag the route with the process ID number of the OSPF router on which the redistribution occurred. And again, remember, this is an external type 5 because that default information originate command is redistributing, right? We're not saying redistribute. We're not using a redistribute command, but it's treating it as redistribution because we end up with an OE2, and so it auto-magically tags it with a tag of 1. And if I go to router 2, I can guarantee you that when I say show run, and I would say show run pipe it to section router OSPF, but Packet Tracer doesn't like that, it's router OSPF 1. And watch this. If I was to do this, and I don't know if this probably isn't going to blow the activity up. So if I was to say no router OSPF 1, and then I'm going to come back here, I'm going to grab all of that. Whoops, we're going to copy this. I'm going to say copy. And so right now we should see that everything is getting ready to go down. But here's what I'm going to say. Actually, we'll let it fail. Do show IP OSPF neighbor. And it looks like everything is down. So I'm going to say router OSPF 9999, right? And then let's paste everything back in. You can see we went from loading to full. Everything is up. That's my process ID. We come back over here to router 1. And let's see if the OSPF link state database, IPOSPF database, looks any different. And it should, but it doesn't. And of course, it doesn't because it's Packet Tracer. So let me demonstrate that. I probably should have jumped over here to make that demonstration real briefly. So we're going to say, let me exit out here, and I'm going to say no router OSPF 1. And we'll say router OSPF 9999. And network, I'll just throw quad zeros in here. Whoops, quad zeros in here real quickly. And area 0, and I'm going to say default information originate, and then let's put a do show IP interface brief, do show IP interface brief. We need a static route ever so quickly. I'm going to say exit IP route. We'll do our quad zeros, quad zeros, and we're going to send this out the fast Ethernet 00 interface. And that's fine, right? So now let's come over to router 9, and let's say show IP OSPF, or show IP route OSPF, not router, OSPF. And do we have it? We do, right? Here's my OE2. So now let's say show IP OSPF database. And that is what we would expect to see. So packet tracer let me down there at the very end, but that is what that tag value is all about, right? And again, if I was doing like a mass redistribution from EIGRP and sending, 100 routes, 1,000 routes, and I wanted to make sure that I knew that, where that routing information was coming from, because again, when I redistribute it in, everything comes in as an OE2, right? It no longer has its EIGRP characteristics and traits from a distance and an administrative distance and a metric perspective. It's now being treated as OE2. So to differentiate between, excuse me, the different redistributed information, we can tag, right? Think of it as like, you go to the supermarket and you can put a tag, they put price tags on things to differentiate the prices, right? And so think of it as just like a price tag, right? And I'm tagging all of the EIGRP AS9999 information so that I can see in my OSPF database here, right, where that external information was coming from. And so that's a very, very important point. I want to make sure we covered that tag value because we see it. And again, packet tracer, unfortunately, let me down here, but that's okay. We jumped onto a real router and saw what that value is all about. Now, back to the bandwidth. And again, it tells you exactly what to do here. So not difficult to make this happen. Let's get into global config and let's make sure that we are still tracing out to router 2. So .3.2, you see that? The second hop there, we always go to router 2 because that is the shortest path. We're going to change that right now. So if I go into interface serial 000, I could say bandwidth, and actually, not change that. I want to make sure I'm getting the right port here. Yeah, so serial 000 must be do show IP interface brief. Which one are they having me change? All right, so good. Okay, so there, I want to make sure that the serial 000 link is this one here. Making sure I don't change the wrong link. So interface serial 000, and they want me to put in here bandwidth. And before we do that, let's see what is it set to. Do show interface serial 000, and you can see that the interface right now, right, it's a serial link, so it's set to the default 1544 kilobits per second. We're going to change that to 64 kilobits per second. Now, we've made the change. Does that change the actual bandwidth or throughput on that interface? No. It doesn't. Remember, when we talked about this on Tuesday night, that command, this bandwidth 64 command, is not downshifting the actual speed at which this interface is sending traffic to router 2. All that command is doing, and we see it here when I say do show interface, we see it here. All it's doing is it's changing that value from the perspective of the routing protocol. So that interface is still going to be able to send it, a T1 speed at 1.544 megabits per second, right? But all we've done here is changed how the routing protocol is going to look at this interface. And now OSPF is going to see that, and OSPF is going to say, whoa, wait a second. When I did my calculation, right, when it came up with the OSPF cost initially, it had calculated it at 1544 kilobits per second and came up with a value, right? A value which unfortunately I did not display, but if I was to say do show IP OSPF interface, we can now see the serial 00. That's the gig interface. I'm looking for serial 000 here. We can now see that this is a point-to-point interface, right? We have our timers, and there is the all-important cost. So the cost has changed. In fact, the cost would have been the same as this point-to-point interface here. It would have been on serial 00. Now, don't become confused here, right? Remember, OSPF only looks at the bandwidth of the interface. This is serial 001. That is the cost, not the bandwidth value. And here's how we get to the cost. And I'm going to have to pull my trusty calculator up here. So remember, the reference bandwidth, or the default value that OSPF uses to come up with the metric or the cost of the link, is 10 to the 8. 1, 2, 3, 4, 5, 6, 7, 8. Let me make sure I get that right. 1, 2, 3, 4, 5, 6, 7, 8. Divided by the speed in bits. 1544 equals, or wait, I did that wrong. I totally did that wrong. Hold on. So it's 10 to the 8. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Divided by, and we're going to look at it in bits per second. So 1544.0, and that should give me, and actually I'm putting the calculation in wrong. It's 64, right? So it's going to round down, and that's where we get the 64. Okay, and I think I'm missing, am I missing zeros? 1, 2, 3, 4, 5, 6, 7. I can't count. Divided by 1544.0 equals. And that's totally wrong as well. So I'm sorry, I'm typing this in wrong up here, but 10 to the 8 is the reference bandwidth. That's where we end up with the cost of 64. So this is the cost, not the bandwidth setting. So when I set the bandwidth to a higher value, or I'm sorry, when I set it to a lower value, it's an inverse relationship. We end up with a higher cost. So the bandwidth goes down. OSPF looks at that and says, hey, that interface is less preferable, not as good as this interface here. And so now when we go to trace, and I trace out, what is the second hop? It's the 10.6, and we're constantly going to take that 10.6 hop to router 3 because we've put the bandwidth value in here. And so here's the problem with using the bandwidth. Not so much in this use case here, but what if we were doing quality of service, QoS, and I had QoS policies applied on this interface right here? I have now just changed how QoS is looking at this interface. So my initial desire may have been to simply adjust the OSPF, to do some layer 3 traffic engineering, because I wanted all the traffic to go this way to get to the internet, right? And I changed the bandwidth here. Now the problem is my QoS settings have been manipulated. And here's something else to think about. What if I was running EIGRP as well in this environment? Yeah, now I've just maybe mistakenly changed how EIGRP is going to behave. And here's the other problem. I didn't make the change over here on router 2. So now we've got a bandwidth setting here forcing traffic this way, right? What happens if traffic comes back into router 2 and this is the more preferred way, right? So now we've kind of created an asymmetric situation. So when you make a change, it's preferable to make it on both ends so that this link from the perspective of both router 1 and router 2 is being calculated and treated the same way. And so the preferred way, the technically correct way to do this, and the preferred way to do this is not to change the bandwidth, right? The only reason, and we talked about this, one of the only reasons to change the bandwidth is that if this was a fractional T1, maybe we got a single DS0, 64 kilobits per second, right? We've got a multiplexer involved, we get a fractional T1. That is the time to go ahead and say bandwidth 64 because that would then accurately reflect the true speed of the interface, right? And the true, I should say, the true bandwidth of the interface. And that's when you would want to do it, but you would do it on both sides because this side is not going to be 64 kilobits and then magically this side over here on a point-to-point link is 1.544. You wouldn't have that, right? You wouldn't do that. So how do we do this in the preferred fashion is we would say no bandwidth 64, right? And OSPF is now going to recalculate and take a look at that, right? So this is nice. Packet Tracer showed us that I did it right after the command. It didn't pick it up, but then look what happened. So it went out to router 3, then to router 2, but we wanted to go just to router 3. And so now we're back to the original case. So how would we do this with the IPOSPF cost command? Well, we would simply make, from an outgoing interface perspective, because that's how it's being calculated, we would tweak the cost here on the interface, but we need to know what that cost is. So I say do show IPOSPF interface, and you can see it's going to be 64. It's going to be 64. And here's serial 00 with a cost of 64. So all I have to do is make the cost on serial 000 worse, right? Less preferred, higher than the cost on serial 001. And the cost for both is 64. So I could literally say IPOSPF cost 65. And that right there is going to be enough. And we'll let OSPF do its thing here and recalculate. And that should be enough to get it to move. And maybe we are not high enough, let's say 60, and actually we'll do this, let's do 100. IPOSPF cost 100 because that is definitely going to get us out of the rounding down range, or it should have. And so this is now interesting. So let's take a look at the routing table here. Maybe we have to clear the OSPF. We shouldn't have to clear it, but Packet Tracer, we don't know. So let's say do show IP route OSPF. Oh, and it's because I'm taking the default, but that should not change things. We should see that we are going out serial 010. Yeah, that should change. Let me do this. Do clear IP OSPF proc. And we'll say yes. Do show IP route OSPF. All right, let me make this significantly higher. And let me make sure, am I in interface serial 000? Let's make sure I'm in the right interface, and I am. So I'm going to say IPOSPF cost. And we're going out to serial 2, and maybe this is tweaking it. Let's do this. Let me see if I make it 10,000. Because that should definitely change. And there we go. And that was enough to get things to change. And actually, I should have done that after I did the clear. But you get the point, right? If I tweak the OSPF cost, the shortest path first algorithm is going to say the better way to go is the southbound route down here between router 1 and router 3. And that is the preferred way to do it, is to use the OSPF cost, because this only changes how OSPF is looking at that link right there, right? And that is critical. And before we go, I want to see that calculation, 10 to the 8th, 1, 2, 3, 4, divided by 1544. I think I'm not supposed to put, oh, kilobits is thousands. That's my problem. I'm sorry. Okay, I'm 1, 2, 3, 4, 5, 6, 7, 8. Did I get that right? Divided by, so 1544 in bits per second, 1, 2, 3. There we go. I was putting 1, 0, and I wasn't doing the conversion right. So it's 10 to the 8 divided by the speed of the interface in bits per second. And since we're looking at kilobits, I need 3 zeros at the end of the 1544. So I apologize there. All right, so that's where we round down, right? And if I was to change the cost to 65, right, I end up with, I don't have to do the calculation, right, because I'm setting the cost. I'm making it greater than 64. And so from an OSPF perspective, the lower route, right, down here from router 1 to router 3 would be preferred. All right, so again, we took the bandwidth off, we lost the 5 points, but that's okay. So this is going to conclude Packet Tracer Activity 10.1.3.4, where we took a look at some advanced features in OSPF. We did a compare and contrast as to what we saw in Packet Tracer with the hello and dead intervals and what we would expect to see with real Cisco IOS. And then we looked at the Layer 3 traffic engineering using the bandwidth command, talked about why you wouldn't want to use the bandwidth command, and we looked at what we would want to use, which is the IPOSPF cost command under the interface. All right, thanks so much for watching. Have a great weekend. I will see you Tuesday night.